Friends, today we are going to describe a very important program of converting a decimal number to its binary equivalent. So, this is the program written on the board. I will just go on to explain this program line by line and put some sample values in the form of a dry run in order to make you understand the concept behind it. So, this program, our objective in this program is to convert a decimal number to its binary equivalent. So, first of all, we have just written hash include stdio.int, which is the file inclusion directive, as you all know. Then the int pen. Then we have taken several variables, including some integer arrays also. So, let us just go one by one. Int a10 is an array named a. This is an array b10, then comes another variable n, then comes another variable which is taken to be a counter variable. That is why I have written it to make you understand. I have written it in the form ctr. This is initialized to 0 at the very beginning, I is equal to 0. This is also initialized to 0 at the beginning, and there is yet another variable j which is not initialized beforehand. So, let us get started with the following lines. Printf enter a number. This number is actually a decimal number. You could have written like this: enter a decimal number, in order to make the user understand what is the input he or she will supply to the program. Enter a decimal number, and this decimal number's binary equivalent is to be determined by this program. So, the number is input by the user by this line scanf %d %n, nothing to explain over here. Now, we come to the logical portion of the program. So, I have written while n greater than 0, that is while the number is greater than 0, we have taken non-zero positive integer for our explanation purpose. For the sake of simplicity, we will go on and try to find the binary equivalents of other numbers for 0 or negative numbers, but that will be dealt with later on. So, now we are taking non-zero positive integers. That is why I have written while n greater than 0, I have written over here ai is equal to n %2. That is, whatever is the remainder after dividing n by 2 will go to the array ai. Suppose the array ai is like this: 0, 1, 2, I is equal to 0 at the beginning. So, the first remainder will be written over here. Then the n will be updated by the slash operation. N is equal to n/2, that is, n will be divided to find the quotient, and that quotient will update the value of n. The quotient will be assigned to the variable n. Then I is incremented by unity, and counter, that is ctr, is also incremented by unity. Both are written as I++, ctr++ respectively. Now, we come to another loop, that is in which I have taken the loop variable to be j, and which will be controlled by the I variable. So, I have written for j is equal to 0, j less than I, j++. What I have written over here, please try to understand, bj is equal to a ctr minus 1. So, that takes care of the calculation which we normally do in case of the conversion of decimal to binary equivalent. So, in order to take that into consideration, in order to care for that, we have written this line, and then we have decremented counter, that is ctr, by unity, that is ctr minus minus. So, this is the iterative process which goes on to find the binary equivalent. So, as I have got the binary equivalent stored in the B array, that is, the B array will be like this. This was the A array, and everything will be taken from this A array to go to B array, and this B array will ultimately give us the binary equivalent. So, I have printed the binary equivalent is for j is equal to 0, j less than I, j++, printf %d bj. Whatever is in the B array will be printed one by one, and after that we are left with nothing but the return 0 statement and ultimately the closing brace of the main section. So, this is the program. You can take it down on your notebooks, and now I am going to explain this program in the form of a dry run by putting some sample values in order to make you understand the total nuances, what are the nuances into this code. So, let us get started with simple input from the user. Suppose I will go by an input 5. So, suppose user gives a value 5 as the n. So, this 5 is the decimal number which is input by the user, and this is to be converted into its binary equivalent. So, let us see whether the binary equivalence of 5 comes from this code. So, this 5, now n is equal to 5 while n greater than 0, yes, n is greater than 0 definitely. Now, we come to this portion, ai is equal to, what is I? I is equal to 0, then a0 is equal to n% 2, 5% 2 means remainder is 1. So, in the A array, suppose this is the A array, I am just going to rub a bit portion in order to accommodate some space. So, excuse me for that. Suppose this A array goes like this, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4. So, this A0 will contain now 1. So, after that what I have done, n slash equal to, n is equal to n slash 2, that is n will be divided by 2 in order to get the quotient. N is equal to 5 divided by 2, what is the quotient? Quotient is 2. So, if you divide 5 by 2, what you will get? 2 2s are 4 and the remainder is 1. So, you have got the remainder and we will take the quotient as 2 and assign it to the value, assign it to the variable n. Now, we are incrementing I by 1. So, I becomes 1, CTR was also 0 at the beginning, now CTR becomes 1 because CTR was 0. So, now we come, because n is equal to 2, that's why we will again enter this while loop for the second time because n is not greater than 0. So, ai will be again, a1 will be n% 2s, that is 2 will be divided by 2, and what will be the remainder? 2 will be divided by 2 to get the remainder 0. So, the remainder will be definitely 0. So, this 0 will be stored over here, then n will be divided by 2 to get the quotient. 2 divided by 2 will give you 1, so that becomes 1. So, now I becomes 2, CTR becomes 2 as well. Now, this 1 is greater than 0, we will enter the while loop for the third time and do the same operations, do the similar operations as is shown above. ai, that is a2 will be n% 2. What is n% 2? N is now 1. 1% 2 means 1. 1% 2 means 1. So, this is the remainder. Then we come to this operation, n is equal to n slash 2 to get what the result. 1 divided by 2, the quotient will be definitely 0. I will be taken to be, I will be incremented to 3. CTR will also be taken to be incremented to 3. So, now we are storing this 1 over here. Now, this is the output from the third iteration of the while loop. Now, again we try to come and see whether we can enter this while loop for the fourth time. So, n has become 0, so we definitely will not be able to enter this loop and go out of this loop and come to this this for loop construct. So, this for loop construct says for j is equal to 0, j less than I, j plus plus j is equal to 0. So, j will be equal to 0, definitely less than I because I is now having a value of 3, that condition is satisfied. Bj, that is B0 will be a CTR minus 1. What is CTR's value? Last value 3, 3 minus 1 means A2, A2 means this is 0, this is 1 position, this is 2 position, A2 means 1. So, this 1 will be put into the array B. I am just rubbing a little bit in order to cater for this, cater for B. and B is like this 0, 1, 2, 3, etc. So B0 will contain A2, whatever is in A2 will come to B0. So this is B0. So this 1 is put into the position B0. So B0 is A2, that is this 1 will come over here. So now J plus plus, J becomes 1 less than 3, perfect. So we now do this, B1 is equal to, one thing I have forgotten to tell you, that is we have decremented the counter by 1 before incrementing the J. So I will just decrement this counter after assigning this A2 into B0. So counter will become now, counter was previously how much? Counter was 3 and now the counter will become 2. So now J will be incremented by unity, J will become 1 less than 3. So now B1 will be A CTR minus 1. So A2 minus 1, that is 1, A1, whatever is in the A1 position will go to now B1 position, that is this 0 will go to this position straight away. So this A1 will be copied into B1. Now let us again decrement the counter by unity, counter becomes 1 and J also is incremented by unity, J becomes 2, which is definitely less than 3. We again enter the for loop for the third time and Bj, that is B2 is equal to A CTR minus 1, that is CTR is 1. So this is definitely 1 minus 1, that is A0. So what is A0? A0 is 1. So this 1 will be coming over here. So this is the 1. So now the CTR is again decremented to become 0. J is incremented to 3, which is not less than 3. The condition is not satisfied. We come out of the for loop and in this way the counter is now 0 and I has become and J has become ultimately the J value has become 3. So now we are going to print the binary equivalent in the form of the by printing the B array from the beginning to the end. So now for J is equal to 0, J less than I, J plus plus, this is quite simple because I is now how much? The ultimate value of I was 3 before we entered the for loop construct. I was having a value of 3. So now J is equal to 3, J less than I means J less than 3. So 0 to 1. So 0, 1, 0, 1, 2, that is less than 3. Up to less than 3, we are going to print these 3 numbers which are stored in their respective cells A0, A1 and A2. So 0, 1, 2, by the 3 iterations, we will print this Bj from left to right by this statement. As you can easily see that I is controlling J and we have printed the B array starting from the left to right in order to get this as our output, that is 1, 0, 1. So this is fairly simple. No need of further explanation how we have printed this from left to right because this is an iterative process to which you are quite familiar. And this 1, 0, 1 will be printed as an output. So let us just see whether it is the same as the desired output or the expected output. See, if we go on to just let me rub a little bit portion over here. So if we just divide this 5 by 2, if we divide this 5 by 2, then we get 2 and the remainder is 1. So this 2 will be again divided by 2, then it will give a quotient of 1 and the remainder will be 0. So this 2 will be again, this 1 will be again divided by 2 to get a quotient which is 0 and the remainder will be 1. And we will go on printing from this bottom to top. So, this is the natural operation, this is the normal operation or the usual operation we do in the digital logic in dealing with the binary numbers. In binary arithmetic, we do this sort of calculations in order to find out the binary equivalent of a decimal number. So, this is the decimal number, you repeatedly just divide it by 2 and take the remainders alongside, and ultimately you go on dividing the binary decimal numbers and their coefficients which are coming and their quotients rather, beg your pardon, and their quotients one by one until the quotient becomes 0. And in this way, what are the remainders which have accumulated on the right side, you need to print them in the reverse order. You get in this order, but you just take the answer to be going from bottom to top. So, in order to get from bottom to top, we are traversing which number? 1 followed by 0 followed by 1. So, it looks both from the same from both the sides. So, there should be no confusion. If it was if it was unsymmetric in pattern, it could have also dealt with the situation in that case. So, never mind about that. But this is a coincidental, this is a coincidence that it is coming to be, it is looking the same from both the sides, but never mind. We are going to print in this manner, that is, we are taking the output to be printed from the bottom to top, that is, this bottom one will be printed as this one, this 0 will be printed as this one, and this one will be printed on the rightmost side. So, our result, our output which is found from the dry run or after putting some sample values into the program, whatever we have got as the output matches with the desired output. Desired output is from top to bottom 101. So, this is the desired output and this is the output from the program. Both of them matches to each other. That proves that this program is correct and is ready to be run on the computer system. So, if you have any doubts or queries pertaining to this program, you can well post your doubts or queries into the comment section so that I can address them. Thanks.